This is 2024 paper 1 question 9, and we're basically given an equation and we just have to sub in. We're told to find c, the volume of the cap, when r is 13 and k is 4. So c will be equal to pi, and then k is 4, so we'll have times 4 squared over 3 times 13 minus 4. And you can just put that into your calculator. Now make sure that you put in just this part, or even if you put in the whole thing, it might give it in terms of pi. But basically you want to find out what this number in front of the pi is, and then just write that number multiplied by pi. And when you get the value of this number, it's 560 divided by 3, and then that's being multiplied by pi. And we're not told any units or anything, so we can just give that as our answer. Then we're told that we have a different sphere. The radius is 8 units, so this is important. So we have 8 units. The cap has a height of y units, and we're told what the volume is as well. And we have to use this and the expression for c above. So we know that c is equal to pi, so I'll write this down. So we know that c is equal to pi k squared over 3, was it? Yep. Times 3r minus k. So that's our equation, and we know that the radius is 8 units. Well, I guess we'll go left to right. We know that the volume for this particular cap is 36 pi y. That's what the volume is. That's going to be equal to pi. Our value for k, well, remember that k is just the height, okay? So k is the height of the cap, it says up here. So our value for k is going to be y in this part. So you have pi y squared over 3 times, and we're told that the radius is 8 units. So we'll have 3 times 8, and then again k in this question is equal to y. So a few things we can do. We can cancel this pi and this pi, basically dividing both sides by pi. We can multiply both sides by 3 up to the left-hand side. And then when we do that, I won't do too much at once. So I'll say that when you multiply the 3 up, you'll get 108y equals y squared times 3 times 8, sorry, is 24 minus y. And you can see we're quite close to the answer here. So obviously, the cap, or the height of the cap, we're told that y can't be 0. So we can divide both sides by y because we know that y isn't 0. But that is a solution to this equation, but we're told that y isn't 0. So dividing both sides by y, we get 108 equals y times 24 minus y. And then we just have to get this into this form. I actually shouldn't have multiplied up by the 3. But if we divide both sides by 3, it's going to look exactly as we have up there. So dividing both sides by 3, we'll have 36 equals y over 3 times 24 minus y. So that's just dividing both sides by 3, and then you can see we get what they wanted. Then we're told to solve this equation. So basically, I guess we're going to multiply the 3 up now. We're going to get 108. So we'll have y times 24 minus y equals 108. And then we'll have 24y minus y squared equals 108. Bring it all to one side. We get that 0 is equal to y squared minus 24y plus 108. And we just have to solve that. You can use the quadratic formula if you want, or you can notice that the factors of 108, one way of doing it is going to be minus 6 times minus 18, and then they add to give you 24. So this factors to be y minus 6 times y minus 18. So that means that y equals 6 or y equals 18. Now we have two answers, and we're told the height, not heights. So, and if we look up here, we're told that y is between 0 and 8, so we can discard 18, and we can say that y is equal to 6 as our final answer. Then we're given a different equation for the volume of a hemisphere. What is x when the volume is 3 liters? So it's important here, the volume for the equation is in centimeters cubed. So we have to convert 3 liters into centimeters cubed. So 3 liters is equal to 3,000 centimeters cubed. So the fact that you should remember for that is that 1 liter is equal to 1,000 centimeters cubed. Or you can remember that 1 milliliter is the same as 1 centimeter cubed. Or you can remember that fact, it's important to know for this question. So then we can replace v with 3,000, because we're going to have 3,000 centimeters cubed equals pi over 12 times x cubed. And then the reason that works is because we have centimeters on this side, so we know our answer for x will be in centimeters, which is what we want. So then we can just rearrange and get x. So we can say that x cubed will be equal to, so we multiply the 12 up, and we get 12 times 3,000. We can divide that by pi. So again, that's just dividing both sides by pi. So the 12 comes up, the pi comes down. And then you can cube root both sides, cancel out the cubed. Or the way that I think is a bit more intuitive is if you put both sides to the power of a third, and this side to the power of a third, then 1/3 multiplied by 3 gives us 1, because we multiply powers like that. So then we get x to the power of 1, or just x is equal to 12 times 3,000 over pi, all to the power of a third. Or again, you can cube root it. And when you do that, you'll get 22.5 because it says 1 decimal place. And it's important, you shouldn't write 22.5 centimeters. Again, they're not too picky about this, but you shouldn't write that because here it says it's x centimeters. So if you wrote x equals 22.5 centimeters, then that means the diameter is 22.5 centimeters. But there's centimeters here already, so we don't need to write centimeters here. For part D then, we're given some information, and for these kind of questions, just write down all the information that we have. So the volume is increasing at a constant rate of 450 centimeters cubed per second. So now the change in volume over the change in time will be equal to 450. What is the rate? So what we want is the rate at which the diameter is increasing with respect to time. So we want dx over dt equals question mark, and we don't know what that is. We only know dv over dt. And we know they told us this equation, and they told us that for a good reason. So let's just differentiate this. So if we differentiate this, so we know that v is equal to pi over 12 x cubed, or v of x, doesn't really matter. When we differentiate both sides, we can get dv over dx equals, bring the 3 down, and what we'll get is pi over 4 x squared. Again, that's just because 3 over 12 is the same as 1 over 4. So we get pi over 4x squared. And remember, we want dx over dt. So if we can take this thing, we have these two facts here, and we want to cancel out the dv's, because if we do that, we'll have an equation with just dx's and dt's. So we can think about it as if we want dx over dt, well, what we can do is we can take our dv over dt, and then what we can do is we can multiply that by dx over dv. And the reason we do that is these two dv's will cancel, and then we get dx over dt. So dv over dt, well, that's equal to 450, multiplied by dx over dv. So we have dv over dx, so we just need to take the reciprocal on both sides. So you can say that dx over dv would be equal to, we can have 4 over pi x squared. So it's important that this is on the top. These are both on the top and the 4 is on the bottom. So when we take the reciprocal, it's like that. Another thing you could do if that's confusing, multiply both sides by dx, and then divide the dv down, and then bring all this stuff onto the left-hand side. Or you can just do it like that. That's just algebra, though, so you can look into that if it didn't make sense. So now dx over dv, that's 4 over pi x squared. So that basically means that dx over dt is equal to this thing. So 450 times 4, that's 1,800, I believe, over pi x squared. So now we know what dx over dt is, and we're told to find what that is. So the rate at which the diameter is increasing with respect to time, that's change in diameter over change in time, when x is 20. So all we have to do now is replace that x with 20. So we can say what we want is dx over dt at x equals 20, and that's going to be equal to 1,800 over pi times 20 squared, which is equal to, when you do it to 1 decimal place, which I believe is what they ask for, yep, you will get 1.4 centimeters per second. Again, they're not too picky about units, but it's a good idea to do that just in case. Finally, in part E, we just have to manipulate this formula, so we need to get h by itself. And it has to be in a certain form, it has to look like that. So first thing, h is under the square root, so we should square both sides. So now when we square both sides, what's important to notice is we're going to have s squared equals, and then when we square the right-hand side, we have a product on the right-hand side. And when we're squaring a product, we just square each thing in the product individually. That's a rule of indices, it's in the log tables, and there's a good intuitive reason for it, which you can find online. So we square each thing individually because they're all multiplied together. So the pi squared, r squared times r squared plus h squared. And we need to get h squared by itself. So what we could do is we can multiply out the bracket, or we could divide across by this. It doesn't really matter which one we do first. Personally, I think I'd probably multiply out the bracket, would be a little bit faster. So we'll get s squared equals pi squared r squared. And then when we multiply this r squared by this r squared, we're going to get r to the power of 4 plus, and then we'll have pi squared r squared h squared. And to make sure that you haven't made a mistake, you could factor the pi squared r squared out of both these and make sure it's the same as this. Then we need to get h by itself, so let's subtract this term on both sides. So we bring it to the other side as a subtraction. S squared minus pi squared r to the power of 4 will be equal to pi squared r squared h squared. Divide both sides by pi squared r squared to get it, because it's multiplied by the h squared right now, so we need to divide to get rid of that. So we'll get s squared minus pi squared r to the power of 4 over pi squared r squared equals h squared. and then we need to square root both sides or do both sides to the power of 1/2, whatever makes more sense to you. Just remember that we do have to use the rules of indices here, and they apply for roots, and the reason for that is because the roots are the same as the power of 1/2. So whatever way kind of makes it easier for you, I'll just do a square root because I know when you have a square root in the answer. So it means that h will be equal to the square root of s squared minus pi squared r to the power of 4 over pi squared r squared. Now we're not fully done. The numerator looks kind of like what we have there, but the denominator is just some number times r. The reason for that is because what we can do to simplify this further is split up the square root on the top and the bottom of the fraction, which we're allowed to do because it's one of the laws of indices. So we'll have the square root of the top thing over the square root of the bottom thing. And then the square root of the denominator, again, you can figure it out whatever way you want to. If you think about it as the power of 1/2, I might actually go through it in detail. I think if you look at it as a power of 1/2, it makes more sense. So we have pi squared r squared to the power of 1/2. So then we have a power on a product. And when we have a power on a product, we just do the power on each of them individually. So this will be to the power of 1/2, and then the 2 and the half will cancel to just give us pi. So again, I'll write the numerator first. We'll have s squared minus pi squared r to the power of 4. So the pi squared to the power of 1/2, that'll just give us pi, and then r squared to the power of 1/2 will just give us r. And now you can see it's in the correct form that they asked us for. So we are done.